Good morning, everyone, and thank you for coming to the Smart Freight Leaders Seminar Series. We're hosting it in person for the first time. We had this series started during COVID and was in association with the other universities, University of Toronto, York University, and Metropolitan University. This is the first time we have it in person here in McMaster. So I'm honored to introduce to you Dr. Shirook, who will speak about the importance of environmental data for smart cities. She has an impressive accomplishment. She's a professional engineer, educator, and entrepreneur. She's the founder and CEO of Ecosystems Informatics Inc., the company that she would talk today about some of the work that they're doing. Has held 33 US and international patents in the field of wireless mobile communication, worked with several leading companies in that area, and also has been involved in research with different universities and also in mentoring capacity, and has published 120 scholarly papers. So well-rounded scholar. This is really what we want to see, people who are successful both on the academic and on the professional side. So it's a pleasure to have you with us, and we look forward to your talk. And we'll have some question and answer towards the end. Yeah, please go ahead.
Thank you very much for the introduction. Today I feel extra special, being the first speaker for your in-person, and also to be able to get a parking spot right in front of the building. It's really made my day. But I guess this talk and meeting all of you and being back at McMaster is something that is very close to my heart. My PhD is actually from McMaster. I was here 2000, started my PhD, and I had a one-year postdoc at McMaster as well. And I also lead research with collaborating with other colleagues at electrical engineering on renewable energy. So I continue to come back to McMaster in different capacities. So thank you very much for inviting me today and for spending your time listening to the talk. What I wanted to bring to the table is a discussion around the power of environmental data when it comes to smart cities. As always, there is a technical difficulty. Is there a way to get the slides moving? The keyboard seems to be.
The page down is not working.
No.
See if I can go to. It should be the, so the normally we have the menu and the items here. Yeah. Oh, that's good. Escape is the key. Yeah, try that. Maybe are we sharing screen? Yeah. Okay.
Yeah,
Good.
okay. Thank you. Okay, so resuming where we left off, talking about the power of environmental data for smart cities. A little bit about Ecosystem Informatics. The company in itself is about, if you're not bothered by this setup function.
If you click the X, maybe it will.
Yeah.
Thank you, that's great.
Yeah, today we're in luck so far. Everything is working based on my knowledge of IT. The company itself is a what we call it next generation air quality data collection monitoring and management solution. It's not just about the data, it's about what you do with it and how you help decision making. I started working on this technology in 2016. It was an extension of my passion to do something for the environment. So in 2016, I worked with the Ministry of Transportation Ontario on a methodology to predict greenhouse gases for expansions on highway. But then in 2019, I took the work forward and started to create a business around the technology. So it was founded in 2019. What we do differently or how we show a differentiation or value proposition is that we use software to calibrate the data, the environmental data. And I'll get into the technology, what that actually means. Because traditional technologies calibrate the device via hardware, we calibrate the data via software. That's the main differentiator. To do that, we use AI, artificial intelligence, multiple layers of algorithms in the cloud, proprietary to ESI, and we have a couple of patents around them. What that enables us to do is enable us to get data block by block. And so we have units that can be moved around to collecting data. So you can imagine the wealth of data that you can collect when you have that functionality. And you can collect it at a parts per billion level. For those who are in environmental, can appreciate that that's a very sensitive and low ambient level for outdoor sensitivity of data collected from outdoor settings. With that, we are able to create heat maps, analytics, predictions, and we're hoping to use this to derive better decision making when it comes to environmental air quality issues. This is what the system is. I mean, 6 years of R&D is kind of summarized to you at this 10,000-foot view. We own the entire system from hardware, which is low profile sensors. That's just 2 pounds, but could take up to 8 sensors. These are our samplers in the field. They sample data, transmit the data in step 2 to the cloud where we calibrate. And then we don't sell hardware. We're not a hardware product. We're a SaaS, software as a service. So what the product is to the customer is the data and the heat maps that they get access to it from the web-based dashboard. Just to give you a little bit of an idea of what the hardware looks like.
Sorry, I said we need a question, but sometimes I have some questions if you don't mind.
No worries.
Yeah, if you go back to the previous slide. So you said you don't sell hardware.
Mm-hmm.
So if you're working with a customer, they would have to get their own sensors?
No.
Or you provide?
We provide it,
Okay.
but it's not, we don't sell hardware in the sense that this is the product.
Okay.
We provide the hardware as a lease or enabler, sampler.
Yeah.
But it's a subscription to the data. But of course, they need the hardware to collect the samples.
Given your work on sensors, you're using them here for environmental assessment and emissions. Do you use sensors for other purposes? Like, for example, we have some applications, project, in fact, we're working on now for tracking food through the supply chain, those kind of things. Is that something you do? So,
I always say environmental data is like flour. You can make pizza, cake, cookies, anything with it. Depends how you look at it, how you analyze it, how you aggregate it. Okay. And I'll go through a couple of examples, but the short answer to your question is yes. We can do all sorts of applications, industrial, government, health and safety, and I'll go through a couple of examples, hopefully that will make things clearer. So this is what the hardware samplers looks like. In a couple of months, actually, we will have a new generation of the hardware. Currently, the hardware that we have is 2 pounds. You can put up to 8 sensors in that, 5 from pollutants. For example, I have a menu here of pollutants. To the customer, it's a menu because they can pick and choose and what they want from it. Sulfur dioxide, nitrogen dioxide, carbon monoxide and dioxide, ozone, VOCs, particulate matter. And depending on the application, you would choose from these pollutant measurements. We also measure meteorological factors, and we use those first to calibrate our AI and also to provide a holistic view to the customer about what's happening with respect to that specific environment. This is a 2 pound. I continue to say that because an equivalent of this from Bosch is 20 kilograms. Just to give you a feeling, and it's 2 pounds that could move around. You see here the picture with the city bus. The 20 kilograms from Bosch cannot move around because once it moves around, it messes up the data. Our AI calibrates on the move. These are some of our scenarios where we've deployed. We have different ways to power, for example, with solar, powering it through a USB just from a vehicle. We've done indoor, we've done outdoor. We transmit data via Wi-Fi and via cellular. So we accommodate different use cases and different customer types, not needing special infrastructure or platforms, if you will.
So for those installations, do you take care of the permits?
Yeah, yes. Sometimes the customer is the city, so
Yeah.
the permit is implicit, but yes, we typically do that. So this is what the product is to the customer. That behind the scene, we simplify things. This is what the customer sees. They access the data through a web-based dashboard. They get all sorts of analysis, wind road analysis to tell you where distributions are going, time series, distributions in terms of heat maps, layers of data. So for example, that figure there on the, depending where you're sitting, on your right, it will be the layers. For example, the first layer is the city transit map. The second layer is particulate matter, which is dust, according to that map. The third layer is nitrogen dioxide. The fourth layer is temperature distribution. So when you put these layers of information on top of each other, what you get is very, very specific insights that can make it easy to digest and draw conclusions from. That's the power of data. And we have it, the data is, the customer can have access to it through our own dashboard or through APIs. We've connected to third-party or customers through their back end with APIs. And it's the business model is that we connect to channel partners and to different platforms. So that's our business model when it comes to how we sell the data. Again, these are different snapshots of what can come out of our dashboard. We take this one step further and we use the real-time data to create scenario-based modeling. So I could tell you what happens 20 years from now for your specific location, because we integrate our real-time data from today with statistical models from the EPA, Environmental Protection Agency in the US. We are experts in those models, so we can create different scenarios and understand the impact of these scenarios and these, for example, initiatives before you even do them. So you can make some decisions based on these preliminary assessments. Our value proposition is that truly cost-effective real-time intelligence to help manage. We manage the entire system for the customer. We ship units. It's plug and play to them. Once they are initiated in terms of power, we hand over, we take care of initiating them in the cloud. It's an automated process. It's therefore very scalable. We actually have units in India. We're shipping units next week to Europe, Estonia, and we have units that served in different purposes, and I'll get through some of these. But for example, wildfires, infrastructure planning, construction, oil and gas, mining, city planning. So that's what makes it easy. So how can we use this in smart cities of the future? Sustainable mobility operations. We can optimize for traffic, optimize for transit, future-ready urban development to create more resilient and sustainable cities, urban air restorations, for example, for remediation efforts after wildfires, and we've done a lot of that work. Smart mobility in the city. How do you get more people moving around efficiently, yet reducing their carbon footprint? And marrying mobilization and urbanization. I mean, cities in the future by 2050 based on UN reports, we're going to have 2.5 billion more people living in cities. We're looking into the era of mega cities. So these people need food, these people need to get around to their jobs, these people need to breathe clean air. So how do we do that? A lot of what we can help with is planning for that. I have a video here that puts everything together and shows two use cases with cities of Hamilton and Milton. I'm going to attempt to play it. So setting the standards for sustainable transit. How can we do that with data coming from the environment? Real-time data from measurements that having units, actually in Estonia, we have units on trams, city trams, so they continue to collect and connect with our database, feeding data. You can create all sorts of insights from those, understand the emissions, understand hotspots, vulnerable areas in the city, and understand where you need to focus so that you can create a better mobility within the city with a greener solution. This is what we did with town of Milton. We looked at their year. They wanted to understand for their year 2031, how do we justify moving the buses into electric buses, how much benefit there is. They wanted to do this so they could ask for funding to push for electrification of their buses. And we worked with them in a two-phase project, and they were able to use that data to push for that funding. Restoration and remediation efforts, looking at policy changes, understanding airborne pollutants and how they impact on residentials, and just looking at how future needs to be looking for people to have a safer air and conditions to live in. This is what we did with the city of Hamilton. They wanted to understand the hotspots within the area close to the port area. This is the downtown area. We did a 6 months project with them, looking at this 25 square kilometer area. That was a 6-month project. We had units on our own patrol cars. And then once that was done, actually, we worked on 2 other projects with them, and I'll get into that a little bit closer. Pioneering the future of green mobility, understanding the impact of having electric fleets. It's common sense to see that the bus, when it's electric, that you're going to reduce pollution, but at the same time, where does that bus first be implemented? I mean, a lot of cities don't have the budgets. Where do you first implement that electric bus to make the most impact? This is the second project that we did with City of Hamilton. Once they understood the pain points of the downtown area, they wanted to reroute the trucks from within taking them out of the downtown core and rerouting them outside of the city. But of course, there's a lot of pushback because now the truck drivers have to drive further. So the project with Transportation Hamilton was to understand the real benefit of moving the trucks from within the downtown area and having them routed outside of the city. What we did with them is a before and after benchmarking exercise with them to understand pre and post the intervention, how we were able to redistribute the pollution from the downtown area. That's why you see it's a lighter area in the downtown. Just how you can harness data to understand how to do infrastructure planning. How do you change your intersections? How do you change speed limits even on roads to reduce pollution? We did a work with the city of Brampton for their year 2041 vision. They wanted to understand in a 10 intersection, if they change the speed limits and change the number of lanes for 3 different scenarios, what would that impact on greenhouse gases? There's so much more that we can do. I'm going to keep it for applications to smart cities, but we've done so much more when it comes to applications with construction, oil and gas, mining, industrial applications, health applications, even agriculture applications. So this data can be used and reused actually for different applications. It's not just for the applications that I showed. I'm going to stop here and have questions, maybe make it a discussion rather than me just presenting. Yes.
I got 2 questions, if you don't mind. The first one is about your scenario planning. So, can you know about the confidence level and how are you addressing the error aggregation? So, for example, obviously that like as time goes by, we know that like future has some uncertainty in it, and it adds to, because you mentioned 20 years from now. So
Yeah.
what is the confidence level in just like 5 years or so? And also the error aggregation, the daily data.
Yeah.
And the other question is that, like, do you provide correlation between these layers of information, or it's open to the companies that like, delve into it and find out if there is any correlation?
Right. Let's start with the first question. Wonderful question. Currently today, there are modeling tools that are used to model the future. And as you can imagine, these tools, whatever you put in, you could be very biased and make it look wonderful or look very bad. These tools today are 25 years old. They were created based on some cities in the US. So they're very statistical and tailored to, because they're based on years of data, they create models out of them. What we do is we bring it to today and specialize. So that's why we reformat the model such that it starts from the city's own data. So that means we're starting from today's data. To your question of how do you model the 20 years from now, we create factors, or we accommodate factors that, as far as we know, are what is in 20 years. For example, temperature rise. For example, in 20 years, 4 degrees, that's expected. We factor that in. We factor in the growth anticipated in that city or town. We factor in the amount of buses that is expected to accommodate that growth. We factor in changes in potential distribution of cars. How many cars are going to be electric? How many cars are going to be obsolete? We factor in the type of fuel that's going to be used in 20 years from now. So what I'm trying to say is that we factor as much as possible what we know today. It continues to be an estimate, but it's a more practical estimate, if you will, because we're starting from things we know today, not from 25 years ago. Things today tailored to that city and factoring in the most, let's say, significant factors that would impact 20 years from now, right? Oh, you had a second question.
Yes.
Sorry,
Yes.
can I just interject? If you don't mind just stopping your screen share, so then it'll record your face talking instead of just,
Sure.
perfect, thank you.
No worries.
There we go.
The second question was
Correlation.
Yes. Actually, that's part of what we do. We don't just give the data. That's the whole idea. The team that I have is a team that is specialized in the technology itself, in the IP and the innovation piece of it, but is also very knowledgeable on environment in general, the meaning of the data, what factors we should look into. So we give digested insights and information. As a matter of fact, for the cities that I presented to you, we provided them quarterly reports, and we present those reports, and the reports are not just showing data. They are showing correlations, factors, indicators. So we do give digested, I call it digested data. You're welcome. Is there another question?
Since you mentioned health, what kind of health data are you targeting? Collect?
So the units collect greenhouse gases and air quality plus meteorological.
Okay.
But when you integrate and aggregate that with, for example, if you wanted to understand and predict how much asthma attacks you're going to have.
Oh, I see.
Right.
Impact of the environment.
Yes. For example, even with COVID, if you put together particulate matter, pressure, temperature, humidity, and carbon monoxide and create a factor, it can give you an indicator of how much potential COVID or virus is in a specific space. So it's how you aggregate the data gives you all sorts of factors. Some of them are used for health purposes.
Thank you.
You're welcome.
I would like first to thank you for being here and for this interesting presentation. I have a few questions. Let me start with the data ownership.
Mhm.
As you're providing the service. So the ownership within your business model. Do you own the data, or data can be shared based on agreements with the customers?
So
Generally speaking.
sure. Always the insights are the property and ownership of the customer because they paid for those insights. Now, the raw data itself, it depends. For example, industrial applications, when we're taking the data on their premises, then they own the data typically. With ambient data, that is, you collect it from going around in streets, it doesn't make sense to own it. It's usually shared. Yeah. So, but we reuse the data if that's that's what you're asking. We can reuse the data from contracts that the ownership is not specified.
Okay, and for third-party customer, can they access data? Or like, for example, a city of Hamilton case study? Like if I approach and, okay, I want to see the data, is it even applicable?
You have to come through us.
Okay.
Yeah.
And then you have to talk to city of Hamilton in order to ensure.
So we actually, for example, we did a contract with one of the universities. They wanted data for their transportation modeling. So they came to us, they contracted us. We went and put out the units, got permits from the city, and then gave the data to that institution. So because the units are in the city of Hamilton, you don't need to go to the city to get the data. You come to us, and we go for the permits. We deploy the units for you, and we give you the data and the analytics, and you have access to the dashboard in real time.
Okay. And for the case study in Hamilton, like how many vehicles were included?
In Hamilton, the city didn't want to put it on their buses because they wanted to move fast. So the thing is, with the city of Hamilton, they don't know which bus goes out on which day and which route, and they wanted a specific route continuously be monitored. So we used our own patrol cars, patrolling the area. We deployed 2 cars at a time to scan the area. The scans take a few hours. It depends on the area. But we repeat that because
Different times.
Because they wanted it to be, AM, PM, weekend, weekdays. The other thing is those are units that are mobile. We have fixed units that have been in Hamilton for years. We continue to have units. So those we don't need to intervene. They're set up and they're powered with solar and they continuously stream data. It's just the mobile ones we need to decide. Do we use the customers' vehicles or do we set out our own vehicles?
Okay. And that streaming is on which time frame basis? Is it seconds or minutes?
So each gas,
Yeah.
each gas, we can have 4 to 5 data points per minute.
Okay.
But depending on the customer, some customers, they say, I don't care about a fraction every 10 seconds. I want to see the data every 15 minutes. So we average it out for them.
Okay.
But we can go down to the level of every 10, 15 seconds, you get a data point. Each data
That's
point
good.
has a time stamp to it and a geolocation stamp to it.
Okay. And you mentioned the AI to like AI enabled technologies. In which the role of AI is it like within data collection or the data processing, or you're using AI in different data?
Yes, we use algorithms in different stages. We use algorithms to clean the data. We use, I would say the AI is the middle piece where we calibrate the data. And then we use algorithms again to create the insights. So it's multiple layers, multiple steps, but the innovation piece in all of that is the calibration via software. That's why our units are very light and small footprint, is because we don't use hardware to calibrate. We use software in the cloud to calibrate. So the hardware is shrunk to the bare minimum.
That's interesting.
Yeah.
Like for someone who worked with calibration before, quality assurance.
Yes.
I think AI to do the calibration.
Yeah. That's why it took 4 years. We actually benchmarked against government stations for more than a year. And I mean, I don't have it in this slide set, but we have the evolution of the AI, how it got better over time. Once you understand how to deal with the problem and what the system is and what the issues are.
What is the average lifespan for a product? So
the sensors could live up to 5 years, 10 years, depending on the scenario, but we bring them back every 2 years, test them, reliability testing, and refresh them if need. So I would say anywhere between 2 to 5 years.
Okay, and you already have case studies where you put those products for 5 years. Like, what is the longest period using?
We're only 4 years old. We're getting,
Oh,
we're
okay.
getting
Yeah,
there.
yeah.
We're getting there, but I would say, we've had a unit in India for more than a year now. That, I mean, to me, that's stress testing, and it's with a customer, so it's not like when it's with us where we babysit the unit and handle it with care. It's been with a customer for over a year now, so I'm optimistic that they can stand pressure.
Thank you.
You're welcome.
Maybe Shirook, I have one question on, it's more maybe seeking some comments from you on, we work with data on telematics. And, we have partners with, that share with us telematics data. And we try to predict emissions through that data, but we don't actually have the kind of data you have. And when we look at your data, you have a lot of data on emissions, but very little on traffic flow.
Yeah.
Did you look at looking at the two, or how do you? So some of the applications that at least some companies and maybe also local governments are interested in is how can you attribute emissions to certain vehicles?
Yes.
So if I measure emissions in a neighborhood, as an example, how can I say that 30% of that emission is due to Amazon online deliveries? That kind of attribution. It's a difficult question. I don't think anyone owns full data transparency on that. So AI may be a solution to do the prediction. Do you work with both telematics and the kind of sensor data you have?
Yes, and actually that's what we did with both Milton and Brampton. We got telematics data from the cities themselves. Okay. And then we created our algorithms, layering the traffic information, even through traffic, right turn, left turn, looking at that at different intersections and seeing over a corridor what the impact is. So we've done that, definitely we've done that. We were talking to the port and they wanted to see, okay, what's the impact? How do I know the spike is because a truck went by or because somebody lit a cigarette around it? Yeah. So exactly, algorithms are able to predict or estimate that event, what is causing that event. So definitely we have, and that's part of what we do with departments of transportation, is not just this is the data for that route, but this is the data, and then they give us information on the telematics, and then we provide a holistic kind of view of things. Okay. We can definitely work with you.
Yeah. Sorry, question about the what Dr. Hassan mentioned. So obviously you are sure about your the data that you have. My question is about the quality of provided data by both Hamilton and Milton municipalities. Was it good? Was it good, or you needed to adjust it based on time series and other models to have a better understanding? To be more specific, I mean that was it consistent through days, or you just had I don't know, 8 to 10 a.m. On Monday this week, then 2 weeks later the whole week, then inconsistency and
It depends. For example, with Milton, we put units on the bus. As long as the bus is on, the unit is collecting data. So wherever the bus goes, the unit is collecting data. When the bus is brought back to the garage and it's turned off, there is no data.
No, my question was about the traffic flow that you received from the municipalities, not your own data.
Oh, okay, yes. They have, so they collect this data. I think they're mandated to collect it for specific times, and depends on their budgets, they go outside of their time. So depends what they give us.
Yeah, that was my question.
Yeah.
My question was about the accuracy and consistency of that data.
Of their data?
Yes.
Well, their data they collected from video analytics.
Oh, I see.
They don't, it's video analytics. And again, I know that because I worked on a project for video analytics exactly to look at traffic analysis. I mean, I've done a lot, but this is what I'm focusing on right now. It's based on video analytics and technology that counts the cars and the type of cars and aggregates the the relationships, like the age of the car, the potential pollution or gas type of the car. So they give you statistics based on outcomes from those video analytics. But I can't comment of how accurate they are. But I think they are, I mean, when it comes to when you put things into the hands of technology, it's a bit more accurate than a human sitting there counting. So I think it's accurate enough for analysis that we need to do.
Thank you.
Okay.
Thank you. Yeah, and
I'm curious about the use of point sources. You had talked about Hamilton Transit and Milton Transit, but you mentioned point source monitoring. I'm curious about if you had if you were kind of putting these things in a city, and you wanted to monitor kind of for a specific area, say there's an industrial area that you're concerned about, or there's one particular area that's more subject to ozone. How dense would you need to have those in order to have good predictive design?
So not special to our technology, but any sampling technology is a local sampling technology. Depending on how granular you need the data points to be. We're talking about fixed sensors here, correct? Yeah. How granular, for example, if you're looking at a downtown area, probably every 100 feet you want to put a unit. But if you're looking at a suburb where, things are looking good, you might want to distribute them further. But that's the whole point of having a mobile unit, because the mobile unit samples anywhere you take it. Therefore, you don't need to have 50 units in your downtown area. You can have 5 units in critical locations and fill in the gaps with 3 other mobile units. That's the whole idea of the mobile units, is what you don't know. So when you know, you go put a unit exactly in that location. And then you continuously know about that location. Does that make sense?
maybe this is a good question, Ken. So Amir is working on the optimal sensor location for sensing. So it could involve a lot of modeling.
Yeah, so I just wanted to know about one more application. Do you think analyzing environmental data can aid predicting accidents during transportation?
It could predict accidents because it could tell you the conditions of the roads and visibility. From that perspective, it could even predict the possibility of happening of wildfire. Well, I don't know if they're wild. A lot of the fires these days, they say wildfires, but a lot of them are intentionally started. So once you know the conditions, it gives you the possibility. One of the projects I worked on was knowing the conditions of the roads. Maybe speed limits need to change. So dynamic speed limits based on road conditions. That's the whole idea of having smart systems, is you use data to make things better. So you're driving and you get to an intersection, there is nobody else driving around, but you get a red light, so you stop. A smart system wouldn't need you to stop, would calculate there is nothing else, so keeps you going in green. So the power of data is very, very, very kind of critical to create better mobility, to create safer environments.
Maybe for Nishit's question, I think I've seen some work that's linking not on emissions, but on telematics data to driver behavior.
Yeah.
So I'm wondering on the emissions. So on the telematics data, they look at harsh braking behavior as an indication of risk of accidents. If someone is just suddenly braking, that could be. That would also release more emissions.
Correct.
So do you recognize those in your data? Is that something easy
Yeah.
associated with driver behavior?
You need to give me the telematics, but what we can, without the telematics, we look at, okay, this intersection is getting more spikes, even though the same number of cars. So there is so much to do the more data you have. There is an optimal speed for the car to emit the least emissions.
Yeah.
There is an optimal way to accelerate or decelerate to reduce emissions. Sudden behavior is always the peak of the emissions. So definitely there is a lot of correlation. It's just that when we drive, we don't think about it. Well, I think about it because now I do all of this. But I think the bottom line is what I conclude after 25 years working in research and smart systems, nothing is an independent event.
Yeah.
Everything is related to everything. Even people that eat and drive, that changes the behavior of the driving. And that changes ultimately, implicitly, the footprint. So everything is connected in my view.
Yeah, there's a lot of work in network science. You had a slide with the layers.
Yeah.
On looking at the interaction between those layers.
Mm-hmm.
I think they refer to it as super network. Where you're looking at possibly not just emissions, but the nature of the road, the traffic, and how they interact.
The roughness of the road. Yes.
Actually,
the modeling techniques we use include roughening the rough surface of the road, how rough it is, whether it's wet or not, whether it's ice or not. So all of these details definitely people before us recognized, and we do recognize them in our work as well.
No more questions. Thank you very much.
Thank you very much.
Thank you. This was very important.
I'm going to attempt to take the jump drive.
I stopped recording.
Do I just end here?
Yeah, you can just hit the stop recording. Yep. Yes.